Good morning, ladies and gentlemen. I hope you're all having a fabulous day so far. Today, I'm going to go through the endeavor of going through the hydrogen oxygen fuel cell. Now, this is a very simple topic to get into your head. However, it's a bit complicated eventually when you think about it and compare it to electrolysis and all that stuff because it becomes confusing. But honestly, the way I will articulate it in this video will make it extremely easy to digest. So, what I want you to look at is this anode, this cathode, okay? In electrolysis, we use these anodes and cathodes to perform a separation technique. So we get a metal on one side, which goes to the negative cathode, and something else on the other side, which goes to the positive anode, because that's going to be negatively charged and opposites attract. Now here, we switch it around. So instead of having our classic panic, so that's positive anode, and then obviously negative cathode, we switch it around. So the anode is negative, and the cathode is positive. So that's the only difference that you need to be worried about right now. Fuel cells generate electricity. Electrolysis, obviously, it's a separation technique. It uses electricity to separate a compound. Now, what happens in a hydrogen oxygen fuel cell? All you need to know is the half equations and the fact that it sets up a potential difference between two electrodes. That's all you need to know to get the marks. So we get hydrogen coming in, okay, through here. We have an electrolyte here, all right? You see this lovely, delightful Atlantic blue? Yeah, that's an electrolyte. So let's draw an arrow there, electrolyte. It's typically potassium hydroxide. And this electrolyte is used so that the H plus ions can pass through from the anode to the cathode. Now, what happens to the H2 as it reaches the anode? Right, well, I'll show you the half equation you need to know. So hydrogen is oxidized, okay? Now you know that oxidation is loss through oil rig and reduction is gain. Let's write that down. So we know that hydrogen is losing electrons. So what that means is that hydrogen, if we draw it out, it forms 2H plus and 2E minus. Okay, that's completely balanced. So that is what's happening at the anode. Now what happens is that these H plus ions, they go through this lovely electrolyte. If my pen bears with me, yeah, there we go. And then they reach here. So we're not going to worry about them right now. The electrons, they go through a wire all the way from here to here. So from the anode to the cathode, okay? Electrons, okay? The way I remember the charges of the electrodes is basically, it's panic, but the opposite way around. So instead of positive anode, it's negative anode. And instead of negative cathode, it's positive cathode. So think about panic, and then just remember for fuel cells, it's still the way around, okay? Now, these H plus ions, they've gone through there. Now, what's coming in through here to meet the cathode is oxygen. Okay, now oxygen is reduced. So we've seen this little half equation for hydrogen. Now, if we look at oxygen, what's going to happen is that it's going to gain H plus, okay, and it's going to gain E minus, and it's going to form water. However, this isn't balanced. And what you're in the exam, you're going to want to deliver a balanced symbol equation. So the way I'd go about balancing this, right, there's two hydrogens on the right, there's one here, all right, we'll sort that out. One oxygen on the right, two on the left. So we need to double it, okay? Now there's four hydrogens, so we put four here. But now we need to balance the charge out because the charge of H2O is 0, and the charges on both sides of the symbol equation need to be the same. So we put 4 electrons, so it's like 4 plus, 4 minus, it cancels out. So that means that is the equation. Let's sort that out, sort the font out. 4E minus, yeah, so 4H plus, 4E minus, O2 forms 2H2O. So that is what's happening at the cathode. Now, if we had to combine and give an overall equation, essentially all it would be that H2 is reacting with oxygen to form H2O. Okay, and we would probably put, right, how many oxygens do we have on the right? 1, make that 2, and then now we've got 4 there, so it's going to be 2 here as well. So that's the overall equation. And the reason that we generate electricity is because there's a difference in charge between the H plus ions and the oxygen. That's the difference in charge between the two electrodes. If you ever get a question in an exam that's talking about electrodes, but it's not talking about hydrogen and oxygen, it's talking about, let's say, copper and magnesium, then it's just talking about the difference in reactivity and the difference in essentially charge. So that's what gives it voltage. That's what allows you to generate electricity, because it allows these electrons over here to flow. So that's all you need to know. These three half equations, the main concepts, and now I'll articulate a bit further about the positives and negatives, and then we'll go through some of the 6 markers that you could be asked. So positives and negatives. Now, if you think about a hydrogen and oxygen fuel cell, one of the positives is that no toxic waste is released when it's disposed. In comparison to a rechargeable battery, it takes less time to refuel. And hydrogen can, I'm going to put can in capital letters because it can, it's not always, can be renewable. Okay. Negatives, however, when you learn in year 7 that you want to test for hydrogen, what do? A lit splint burns with a squeaky pop, right? So that's what you need to think about right now, because hydrogen is flammable. So that means that, let's say you've got a nice little car, you've got your Audi RS3, and you want to make it hydrogen powered. So what happens is that if even a tiny little spark from the engine or from God knows where, let's say you had a hybrid engine, you had a bit of engine and a bit of hydrogen fuel cell. Let's say even a little spark from that engine mixed with the hydrogen, the whole Audi RS3 would just go, it would explode. And that is what I'm trying to get at. Hydrogen is explosive when mixed with air. Also, hydrogen is also a gas. That means that you're going to need to be able to have a vessel or a container to store the hydrogen. This is going to take up a lot of space. So hydrogen is a gas, takes up a lot of volume. And then finally, hydrogen is typically produced by burning fossil fuels. Because you need to burn fossil fuels to have the energy to gain the hydrogen, essentially. But you don't need to worry too much about that. You just have to say that it's typically getting the hydrogen in the first place. You have to use non-renewable interventions. So these are the positives and the negatives. Hydrogen is explosive. It's a gas, takes up a lot of volume. It's typically produced by burning fossil fuels. No toxic waste released when disposed. Less time to refuel than rechargeable battery. And H2 can be renewable. So I think those are the 3 half equations. That is basically what you need to know. And the only thing that I need to add is that a potential difference is formed. You have to include this, otherwise you don't get the mark, because that's essentially how it generates the electricity. So thank you for watching, ladies and gentlemen. I hope you enjoyed this video. Put down in the comments anything you didn't understand, and I'll try and go through it with you. I'll go through some past paper questions if you want me to. Just put in the comments what you want me to do, and thank you for watching.